Hello, I am Vlad, and I'm here to discuss with you how to answer question 1 of your probability assignment. The assignment question is titled Surviving Another Day with No Falls. You are asked to calculate separately the probability of falling given that you have not fallen in the previous days for cases and controls. In the dataset, blanks indicate patients who have not fallen in the 9 days examined. The question further states that you can do this task by counting number at risk, number with first fall, and number with no falls for each of the 9 time periods. Note that the number at risk for the current time period is the number at risk in the previous time period minus the number who had their first fall in the previous time period. In order to accomplish our task, we need to first plan out a process of getting to a solution. So let's explore the dataset. When you open the data, you will see that it is not flat. It is not ready for easy processing or analysis. The dataset has 4 columns: ID for cases, days to fall for cases, ID for controls, and days to fall for controls. We can actually flatten this data to make it easier for analysis. This will convert the data into a table with just 3 columns. The first column will indicate the patient ID. The second column will indicate the group, whether the patient belongs to the cases or the controls group. And the third column will just indicate the days to fall. Once we have converted the data set into something that we can easily analyze and process, we can proceed with creating probability tables for cases and controls as given in the instructions. The probability tables will have a structure similar to the ones shown in this slide. The first column will be the group. It will be either cases or controls. The next column will be day. It will indicate the day of the experiment. So there will be 9 rows for each of the cases and controls, one for each day of the experiment, 1 through 9. The third column will be the at-risk patients, those who have not fallen yet. So that means, for example, for the cases group at day 1, 3 patients in the cases group have not yet fallen in day 1. 3 cases have not yet fallen on day 2. On day 6, there are only 2 patients have not yet fallen. The next column will be first fall. This will indicate how many patients have fallen on that given day. Here you will see that, for example, cases, there are no people, no patients who fell on the first day, no patients who fell on the second day. There was 1 patient who fell on the fifth day, and 1 patient who fell on the ninth day. The next column is without fall. This just measures those have not fallen yet after that day. The formula for without fall is the number at risk minus the number who had their first fall. Okay? This means that for day 1, in the cases group, since there are 3 at risk and no one has fallen in the first day, numbers without fall is 3. On day 5, there are 3 at risk, but there was 1 who fallen at that day, so there are only 2 without fall. The next column is the conditional probability. It is calculated as without fall divided by at risk. So for day 1 in the cases group, it's 3 divided by 3. For day 5, it's 2 divided by 3. For day 9, it will be 1 divided by 2. And the final column in the probability table that we are constructing is the cumulative probability. It is just the product of all the probabilities from day one up to that current day. So for day one, there's just one day, so we just have one, and so our cumulative probability is one. For day two, it's the product of the probability for day one and the probability for day two. For day five, it is the product of day one to five conditional probability. So 1 times 1 times 1 times 1 times 0.67. For day 9, it will be the probability, the product of all conditional probabilities from day 1 to day 9. Now that we know what we need to accomplish in order to solve this assignment, we can proceed with coding it in R. So how do we solve this assignment in R? The first thing we have to do, of course, is to read the dataset and inspect the dataset. So we do that using read CSV, and let's look at the data frame. We can see it's the same as we previously planned, where it's not flat. So the next stage is to flatten the data, where we will use an ID column, a group column, and a days to fall column. I will do this step in I will do this step in three steps, sub steps. So I will get the cases first, and then get the controls, and then join them together. But you can also do a different process as long as you get to the same flattened table. So let me do that. Our final data frame is flattened. As we can see here, we have a column for ID, a column for group. There are three patients with in the cases group and four patients in the controls group, and a column for days to fall, where NA denotes those who have fallen in the entire 9 days. Now that we have a flattened table, our next step is to create the probability table. The first step to do that is to create the structure of the table. We wanted 9 days for each of the two groups. So this is the steps that do it. Okay, we get 9 days. We get the unique groups, which are cases and controls, and then we create an expand grid, which will create that 18-row table, right? 9 days for group for the cases group and 9 days for the control groups group. And then we will initialize the other columns at risk, first fall, without fall, and conditional probability. In order to put values in each of those 18 columns, we will loop through that table. A loop, for loop, will go through the table 18 times, one for each day, for each group. Okay. So how will the loop function? At each row, it will get the group and the day that it's trying to process. And then it will create a subgroup of that data frame. So for example, we're processing cases, it will create just a table containing all the cases data. If you're doing controls, it will create just the controls data, a table just for the controls data. Then I will get the number of patients for that particular group. So if it's for cases, I will get 3 patients, and if it's controls, I'll get 4 patients. This is the baseline for our at risk column, because at the start of our experiment on day one, all of them are at risk. None of them had fallen yet. Then I will count those who have fell before. And once I know those who have fell before, by counting those with days to fall before the current day, I can know the number of at risk. Number of risk at risk is the total number of patients minus those who have fallen before. right? And then I will just count how many patients fell on that day, meaning the days to fall column is equal to the current day. And once I have that count, I will put that value into the first fall column. The without fall column is much easier to control to calculate. It is just at risk, the number at risk minus the number who had their first fall. And finally, conditional probability can be calculated as the number without fall divided by the number at risk. So let me run that for you. Once we have the values for all the other columns, we can now calculate for the cumulative probability. Calculating for the cumulative probability in R is easy. It's a sub function of the average function in R. So we just use the average function, AVE, enter the column that we want to calculate, condition on, conditional probability, any groupings that we want. So we will group it based on cases or controls, and we will input a parameter for the function, which is cumprod, which just means cumulative product. And it will create a cumulative product of the conditional probability column grouped by the group, the group's column. And once that's done, we can validate that we have created a flattened table for cases, as you can see here, and for the controls group, as you can also see here. Now that we have this probability table, we can proceed with creating the graphs. We recommend to create a line graph. So in ggplot, you can create a line graph by adding a parameter called geomline. We also want to plot each and every point in the graph, so we also use the geom point um, layer. Okay, so we will plot the day in the x-axis and the conditional probability in the y-axis. And by doing so, we will create a line graph for the probability of no falls, given no falls so far. Okay, so when we run this graph, we will get the graph shown on the lower right. The probability of no falls given no previous falls. And it is grouped by cases and controls. So how do we do that? We put this um, parameter in color equals group, and it divided the graph into group and cases and change the colors. We also want the graph for the probability of no false in start. So in order to do that, we will plot day versus cumulative probability instead of conditional probability. We will still separate them by group. We will do a line graph. We will plot the points. And let's run the graph. And as you can see on the bottom right, we have the probability of no false in start. And this is also what you call the survival curve. So that's it for the assignment. Good luck. And if you have any questions, feel free to reach out. Thank you.